Hello there, Priyank here. Today we are going to talk about how materials impact our day-to-day life. We use all kinds of materials on a daily basis from the time we wake up, like toothbrush, coffee cups, the car we drive, the materials in the car, such as the windshield and the chassis, the bags we carry our groceries in, and even the airplanes we travel on. Today, we are going to take a flight into the aviation industry and see how it has changed from the cost and safety perspective. Air travel is considered a very normal thing in today's day-to-day life. According to the National Air Traffic Controls Association, there are over 87,000 flights daily only in the United States. Air travel is also the safest way to travel. Material science plays a huge role in making it safe. Engineers have to take into account so many factors. For example, have you ever thought about why windows on airplanes are curved on the edges? Well, it was discovered that if the fillet radius is small, then their internal stress does not have enough space to get redistributed. Thus, the actual stress becomes more than the theoretical stress. This increase in stress due to sudden change of geometric shape is called stress concentration. Here we can see in the finite analysis software that as the fillet radius goes up, the stress concentration reduces. This is the reason why we provide sufficient fillet radius on airplanes to allow redistribution of stress and avoid disasters like this. Secondly, have you ever thought why airplanes don't use iron instead of aluminum? It is because iron can have a ductile to brittle transition at low temperatures at high altitude, which can cause failures. Airplanes also have to be accounted for pressure difference inside the cabin and out. While the airplane is at high altitude, the pressure inside the cabin is higher than outside, which creates a stress on the entire cabin from the inside. The airplane should be free of any critical internal stress which can cause catastrophic failure. Unfortunately, in the real world, materials tend to have some internal cracks. Engineers have to figure out the critical stress at which the crack may cause a failure. We use this equation for such calculations. With all the stress an airplane goes through over one flight is tremendous. With huge numbers of flights per day, a plane must be safe enough to travel numerous times. A Topkin material called fatigue covers that. Our S-N curves represents fatigue by showing us the amount of cycles a material can take over a certain amount of stress. An airplane must always be under a critical fatigue limit to avoid failure. Finally, nowadays airplanes are being made more energy efficient by making them as light as possible. Like the new Boeing 787 makes use of composites to its structure to make it light and thus consume less fuel. Boeing says the airframe is comprised nearly of half carbon fiber reinforced plastic and other composites which offer weight savings on average of 20% compared to more conventional aluminum designs. It is also found that since composites are great at handling tension better than aluminum, they do great with fatigue, since an airplane is mostly tension-loaded system. I hope you find this video helpful and spark some interest in material science. Priyank checking out.